Hello everyone. So today we're going over solving inequality with quotient for 1.7. This is the last thing we left it last time. We left the exam. We started for the example is 1 over x, 1 over 1 plus x over 1 minus x greater than or equal 1. So here is the equation again. It is 1 plus x over 1 minus x greater than or equal 1. So last time I gave the steps for how we can solving the quotient inequality. So the steps again is number 1 steps. So the steps again is again, first of all, 1, move all terms to one side. Number 2, find the zeros. Number 3, find the sign. And the last one, number 4, solve. This is the steps how we can solve inequality, the quotient inequality. Quotient inequality means we have a fraction like this, 1 plus x over 1 minus x greater than or equal 0. So, okay. So last time I start a little bit for solving this kind of example. So we move all terms to one side. I subtract the one from both sides. So after I subtracting the 1 from this side, this will be cancelled out. 1 minus 1 is 0, the 0. And here I get 1 plus x over 1 minus x over 1 minus x minus 1 greater than or equal 0. Also, I like solve this one because here we have over actually 1 over 1. So this is actually over 1. And I make the denominator equal by multiplying the 1 here and this one, numerator and the denominator by 1 minus x. So I'm multiplying the both side for this one by 1 minus x. I mean both side, the numerator and the denominator. So here I multiply this by 1 minus x. And I'm multiplying this by 1 minus x. Then I solve it and I simplify it until I get 2x. I start solving this and I simplify it until I arrive at 2x. Here 2x over 1 minus x is greater than or equal 0. This is where I arrived last time, I think. Then I start talking about the zeros to find the 0 for the numerator and the denominator. I said the 0 here, number 3, find the 0. Number 2, the step number 2. This is step number 1 here. Number 1. Here's step number 2, find the zeros. So the 0 for the numerator here 2x is making 2x equal 0. So I divide both sides by 2, dividing this side by 2 and this side by 2. 2 divided by 2, they cancel out, they give me 1. Then after that, this is mean my 0 here, x equals 0. This is the first 0. This is the 0 for the numerator. Here, the numerator. This is for the numerator. Now for the denominator, the same step, the 0 for 1 minus x is, by making this equal 0, is 1 minus x equals 0. Then what I should to do here, 1 minus x equals 0. How can I find the 0? What I should to do here, 1 minus x equals 0. How can I solve equation like this? Any idea what I should to do here? Add x for both sides. This is correct. So I have to add x for both sides. When I add x here, they will cancel out. They give me 0. Now 1 equal x, or x equal 1. X equal 1. This is the second 0 for the denominator. This is for the denominator. Now, next step is to find the sign. Step number 3, find the sign. So I have to graph. So I'm moving to the next slide. Give you 1 minute. So find the sign. I should to draw the real line, and I have to put these zeros on the real line. Then I have to pick any numbers to check what is the sign on the real line. So step number 3, find the sign. Here number 3. This is my real line. And in this real line, I should to put the first 0. I find it, the zeros, I find it from the numerator, x equals 0. So this is the first 0 here, x equals 0. And also the 0 I find from the denominator. The 0 I find from the denominator is x equal 1. But here it should be open circle. The zeros for the denominator should be like open circle like this. Any 0 in the denominator should be like open circle like this. Now pick any number greater than 1. Pick any number greater than 1. And plug it inside the equation 2x. So my equation is 2x over 1 minus x is greater than or equal 0. But like last time I said, you should to hide this and plug it inside the equation to check the sign. Okay. Here I get some position. Richard said take the 2. So I'm going to take the number 2 here. I'm going to take number 2 and plug it inside this equation to find the sign. So 2 times 2 over 1 minus 2. 2 times 2 is, what is 2 times 2 here?
4.
4. And 1 minus 2 is? What is 1 minus 2?
Negative
Minus
1.
1. Exactly. So 4 over minus 1 is? Negative 4. What is the sign here? What's the sign for the negative 4? Is negative. Is negative. So here we check the 2. So for the 2, I get sign negative. So all these numbers here should be negative like this. Now pick any number between the 0 and 1. 1/2. Good. So I'm going to take 1/2. 1/2, plug it inside the equation, the quotient here. 2 times 1/2 over 1 minus 1/2. 2 times 1/2, what I get here? 2 times 1/2. What is the answer?
1.
1, correct? And 1 minus 1/2.
1/2.
1/2. 1 time 1 over 1/2 is actually 1 times the reciprocal for the denominator. What's the reciprocal for the denominator? It's 2. Times 2 is 2. What is the sign? What's the sign for the positive? So here in the middle should be positive like this. The last interval is any number less than 0. Pick any number. What number would you like to choose?
-1.
-1. Plug it inside the equation. 2 times -1 over 1 minus -1. 2 times -1, I get -2 over 1 minus -1 is 1 plus 1 is 2. And I will get here minus 2 times divided by 2 is 1. So -1. What is the sign? What's the sign here? Here, multiplication. The sign is negative, exactly. So the sign here is negative. So here I get negative, negative, negative like this. Okay, my question now, we have to remove this green box here like this. And I should to know, I should to give the interval such that 2x over 1 minus x is greater than or equal 0. When this will be greater than or equal 0, when this will be positive or equal 0, in which interval this will be positive and greater than 0. So as we look in the line, I see here negative. All the numbers from -infinity to 0 will be negative, and from 0 to 1 will be positive, and greater than 1 will be negative. If I plug any number greater than 1 inside this equation will be negative. So when this equation will be positive or 0, when this will be positive or 0, in which interval on the line? Bilal said 0 greater than 1. 0 greater than 1. Another student, Anta, said from -infinity to 0. But from -infinity to 0, the sign is negative. Look, negative, 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 negative. I'm asking when this will be positive or 0. Bilal said from 0, and the 0 is closed until 1 is open. This is correct. Rasher said from 0 to 1, but the 0 is not including. This is correct, but you should to include the 0. Why? Because the question here asking when this will be positive and or 0. See the or, this you see the equal 0, so it will be equal 0 at 0, but the 1 is not including. So the answer set here, the solution, it should said here number 4. So the answer, the set for solution, the solution set. I'm going to write it here, the solution. I'm going to do it here, the solution set is from a closed interval at 0 until 1, and the 1 is open because it's not including. Okay? Any question for this? Makes sense what we did here? Why is the 1 not included? Because the 1 is a 0 in the denominator. And the 0 in the denominator, look, the 0 for 1 minus x, you see here, is x equal 1. The zeros for the denominator should be outside the interval, should be open circle. Always, any 0 for the denominator should be open circle, because we cannot plug the 1, or we cannot be, the denominator cannot be equal 0, because any number over 0 is undefined. If we plug here 1, I get 2 times 1 is 2 over 0, and 2 over 0 is undefined. Yes, the denominator always outside, exactly. Here I get the question, so the denominator are always outside? Yes, always outside. Because the denominator cannot be 0. Okay, any question? Okay, so we finish from this section by finishing this example. Now let's go to 2.1 functions. 2.1 functions. Okay, so first of all, we have to know the function is look like a machine like this. This is my function. It is a machine. They have input and output. So this is my function. It's look like a machine like this. Like this. It has input and output. This is the input for the machine, and this is the output. So here I can write down function is a machine. So this machine, I'm going to name it as f. F, the name of the function, f or L or S, whatever the function has letter. And this machine has input. The input like this. This machine has input. The input like variable x or any like number like x. This is my input. Put it in the red color, input. Here, input. And also they give me output like this. The output is f of x. So the input is x, goes inside the machine, and then they give me output is f of x. F of x. This is output. The input here, the variable x, is taken from a set. Let's call it a set, the set A. So it's taken, this is taken from the set A. This is taken from set A. And this is also taken from the set B. F of x is come from or is coming from set B. So my question is now, also we should to know every input has only one output. This machine, they give me only for every input, they give me only one output. This is very important things here. Every input has only one output. Okay. So who can now, after I give all this information, can define me the function? What is the meaning of function in math? Can you give me the definition of the function in math? What is the meaning of function? Do you know any idea what is the meaning of function? Did you hear about this in before? Okay, so I'm going to give the definition. The function is like a rules. A function f. I'm going to call the function f. We have different letter m, s, whatever you need, but I'm going to take the function f is a rules that assign to each element x in a set A and the set A exactly one element exactly one element in a set B. I mean like exactly one only one input in a set B called f of x. This is the definition of function that connect or assign each element x in set A exactly one element in set B. Every element in set A has only one element on set B. So what is the mean of A here? What's the mean of A? Set A and set B. Any idea what is the mean of set A? Like x coming from the set A and B coming from the set B. I mean f of x coming from the set B. What is the mean of that? What is the mean of A or B? Did you hear about Antash said the relation between two variables like output and input? This is very nice, correct. Relation between input and output. But every input, we have only exactly one output. Every input takes exactly one, I mean like every input has output, exactly one output. Now, I said the input comes from the set A. What is the set A? Did you
The
hear
set of
about
ordered
domain?
pairs.
Did you hear about domains, stuff like this? Domain and range?
Yeah.
Yes, so X come from the domain. The set A is the domain. So x coming from the set A, the set A is called the domain of the function. So here, what is A and what is B and B? So I'm going to define what is the mean of A and B, like from before. Like I said, A and B. So A is the domain and B, it's the range. So A is the set of the domain and B is the set of range. A is the set of the domain, B is the set of the range. Okay, again, what is the mean of domain? Like I said, A is set of domain. What is the mean of domain? Domain of function. So I have another question here. What is the mean of domain? Anyone has know what is the mean of domain? Exactly, Aziza. All possible values of x for a function. Exactly, that make the function define. Like all possible input that make the function define when I plug it inside the function. Because some values, if I plug it inside the function, they will not give me a value or will be undefined. So here I can say is a set of all possible input or inputs. Now, what is the range? This is the mean of domain. Now, range. The same things, but instead of inputs, we have to change it to what? Exactly, Amr. All possible outputs is a set of all possible outputs. So the inputs is called domain, the outputs called range of the function. So now just we know like general idea, what is the mean of function, what is the mean of domain, what is the mean of range, what's the input, what is the output, stuff like this. This is what we should to know in the first part of this section. Definition of function, what is A, what is B, what is the domain, what is the range. Also we can like, there is another way to picture the function. So it's called by using the diagram. So we have another way to picture a function is by arrow diagram. So my question here, I can give example for this. Example now. Example. The example is which of this two diagrams satisfy to be a function. Yes, here I get, yeah, can you go back a second? Yes, here. Okay. Now, which of these two diagrams? I'm going to give you two diagrams. Here is the first one. This is the first one. And here's the second one. Which of these two diagrams represent or satisfy to be a function? Okay, so in the first set, this is my set A. It has 1, 2, 3, 4. Here's 1, 2, 3, and 4. And in set B, we have 3 elements. 1, 2, 3. It's 30, 60, and 80. So for the first one, here 1 goes to 30, 2 goes to 30, and the 3 goes to 60, and 4 goes to 80. And for the second one, here I have 4 inputs, 0, 1, 2, 3, again, 1, 2, 3, 4, and this here in the second set I have 3 elements. First one, second one, third one. This is 30, this is 60, and this is 80. For number 1, 1 goes to 30, 2 goes to 30, 3 goes to 80, and the 2 goes to, again, to 60. Okay, for the first one, first diagram, does this diagram represent a function? So first of all, to know the answer, we have to go back to the definition. A function f is a row that assigns to each element x in a set A exactly one element in a set B called f of x. So every element in a set A, x, should be take only one element on the set B. So this is my set A, this is my set B. Does this one represent a function? This is my A here, this is my B. Does this diagram represent a function? If we look into the 1, taking 30, 2, take 30, 4, 3, take 60, and 4, take 80. Anta said yes, and the answer is yes. It represents a function because every element in the set A takes exactly one element in the set B. So if we look into the 1, take 30, 2, take 30, 3 take 60, and 4 take 80. So each element in the set A take exactly one element in the set B. Because the input only has one y. Yes, no, it's not. Yes, exactly, has only one y variable. This is correct, Anta. Now for the second diagram, does this diagram represent a function? If we look into the 1, take 30, 2 take 30, and also 2 take 60 again, 3 take 80, and number 4 does not take anything. Anta said no. Why it's no?
Because the two have two different Two
variable.
different y values, yes.
Exactly. What about also the 4? Does 4 take anything? Does the 4 take any value from B set, from the set B? No. And this is also wrong because in the function, should every element in the set A, every element, I mean, 1 should take take an image, 2 take an image in the B, 3 take a value in the B. Also the 4 should take a value in the B. So the 4 here does not take anything. So this is not a function again. So the 2 takes 2 value, and this is not correct because every element should take only 1 values. And the 4 does not take anything, and this is wrong also. So here I can say yes, because every element in set A take or has one output, take one value from set B. Here no does not represent a function because number 2, because 2 in set A takes 2 value. 2 values are 30 and 60. Also, number 4 in set A does not take anything, take any value from set B. So the answer here is no, because 2 takes 2 value is 30 and 60 from set B. And also number 4 does not take anything. And it should take at least one, like number 4 should take one variable from B. Should take only one variable from the set B. Any question? Okay, now we can give you a function and we can evaluate the value for the function. I'm moving to the next slide. So the example now, a function f is defined as f of x equal x squared plus 4. So my function is x squared plus 4. This is my function. A function f is defined as f of x equal x squared plus 4. Here we have 2, x squared plus 4. So my question now, number 1, evaluate f of 3, comma, f of minus 2, comma, f of square root of 5. Number two, the question number two, find the domain and the range of the function f. Number three, draw a machine diagram for f. Okay, who will do the first one? Evaluate f of 3.
So you substitute the 3 with the inside the x.
Exactly, we substitute the 3 inside the function f of x. So number one, here f of 3, we plug the 3 inside this function. What I get now? Who will do it? Or
You get
Anta?
13.
3
3
square plus 4, right?
4. Yes. 3
What I
squared is
get?
9 plus
9
4
plus
is
3
13.
is 4 plus 4 is 13. Thank you. F of minus 2 is same idea. Plug it inside the function. Minus 2 square plus 4. Now, minus 2 square is 4 because the minus square is positive and the 2 square is 4 plus 4. And 4 plus 4 is 8. Last one is f of square root of 5. Who will do this one? We'll do this one. Square root of 5. F of square root of 5. Bilal said is 9. Aziza said also 9. Let me check. So plug the square root of 5 inside the function. Square root of 5 square plus 4. The square root of 5 is 5 plus 4 is 9. This is correct. 5 plus 4, I get 9. Correct. Now, question number 2. Find the domain and the range of the function f. What is the domain? As we I defined it last in the previous slide. What is the definition of the domain?
The x values.
All possible x values. All possible, not any x values. The possible x values. All possible input. Okay. Can I plug the 0 here inside this function? Is it possible to plug the 0 inside this function of x equal x squared plus 4? Yes, if I plug the 0, they will be defined, like Aziza said, yes. F of 0 is 0 squared plus 4, and 0 squared is 0, plus 4 is 4. So f of 0 actually is 4. So they give me answer, correct. What about if I plug positive numbers here, like f of 1, for example? Can I plug positive numbers inside this function? They will be defined like f of 1. They will give me what? 1 square is 1 plus 4. They give me 5. F of 2. They give me answer also. They will be like fine. F of 3. Yes, will be defined. They give me answer. So all positive numbers are defined. What about the negative numbers? Can I plug the negative numbers inside this function? And after I plug the negative numbers will be defined. Can I plug negative numbers inside this function? Like minus 1, minus 2, minus 3, to minus infinity? Who said yes? Can I see in the chat box who said yes? Can I plug negatives inside this one?
Yes.
Who else said yes? Amr, can I say I plug negatives here? Aisha, can I plug negatives inside this function?
Like -1.
Like -1? Yes, I can plug negatives. They will give me like, they will be defined if I plug any negatives, -1, -2, -3, any negative number and plug inside the function will be defined. They give me answer. So what is the domain here? What I can say about the domain? What's the value can I plug inside this function? So I can plug the 0, I can plug the positives, I can plug the negatives. So what is the domain here? So I can define the domain here as from -infinity to infinity. All these values, I can plug it inside the function and the function will be defined. Or I can set here all real numbers like this, R. Mean here are all real numbers. Now, what is the range? So the question is find the domain and find the range. What's the mean of range? What is the range defined? What is the definition for the range?
All possible y values.
Yes, all possible output or y value. Okay, so what's the all possible output for this function? If I start from the 0 here, if like the 0, what I get here? F of 0, what I get? F of 0 is 0 plus 4. And the answer is 4. Exactly. Michael, Laila, correct. What is f of 1? 1 square is 1 plus 4 is 5. Correct. What is f of 2? 2 square is 4 plus 4 is 8. Correct. So as I see here is starting from 4, 5, 8, and is going up and up to infinity. The numbers, the answer, after I plug numbers here, 2, 3, 4, 5, all numbers goes to infinity, become large and large. Okay, what about if I plug now a minus number, like f of -1? What's the answer? What is the answer? -1 is -1 square is 1, and 1 plus 4 is 5. Michael is 5, is not 3. Okay. What is about f of -2? F of -2 is, what is the answer? -2 square is 4, and 4 plus 4 is f of -2 is 8, yes. And as we see here also the numbers goes up. So starting from 4, 5, 8, and if I plug the number negative, the same thing is 5, 8, and goes up. So what is the range? What is the output? Shell said from minus infinity to infinity, but it doesn't give me like the output does not give me 0. This function will not give me 0 at all. There is no value. If I plug it inside this function, they will give me 0 or negatives, like you said, from minus infinity to infinity. But if we're starting from the 0, they start from the 4 and above. 4, 5, 8, like this. Yes, Laila, 4 and up. So I can here say the range starting from the 4, and the 4 is enclosing the interval inside the interval to infinity. This is the range from the 4, 5, and goes up. And the same things, if I plug negatives, they give me the same answer. Look, f of 1 is 5, and f of minus 1 is 5. F of 2 is 8, and f of minus 2 is 8. So as I see here, all numbers starting from 4 to infinity. F of 1 and f of minus 1 the same answer. F of 2 and f of minus 2 is the same answer, is positive 8. Same things for f of 3 and f of minus 3. Same answer, the same, exactly. So as we see here, the output is starting from number 4, and the 4 is including and goes to infinity, positive. Or I can define it in different way here, or I can say y such that y is greater than or equal 4, like this. Y such that y is greater than or equal 4. Now the last question, the example, draw a machine diagram for f. Like this. So the last example, we did the same things here before. We're going to draw like a machine diagram, like the previous one, in the previous slide. Okay, let's do it together. Like this one. Okay, so here is the diagram. It should be like this. This is the input here. And this is the output. Should be like this. Okay, this is the function f. The name for the function, our function is f. So this is my function f. Here's machine. Here is the input. The input all x values. And there's the output. The input here is the input for the here is x. The input is from minus infinity to infinity is r. X belong to the minus infinity to infinity. And the output is y, and this y or is f of x, such that f of x belongs to the value from 4 to infinity. Any question for this example? Any question for this example? Okay, so we have another example. Evaluate each function. So here's example number 2. The question is, if my function f of x equal 3x squared plus x minus 5. The question is, evaluate each of number 1 f of minus 2, number 2 f of 0, and number 3 f of 4. So the function again is f of x squared. Here x squared. Okay, who will do the first one? F of minus 2. Number 1, f of minus 2. Just plug it inside the function. What is f of minus? Is 5, as Aziza said. So let's check. 3 times minus 2 squared plus minus 2 plus 5. And minus 2 squared is 4. 3 times 4 is 12. Plus minus 2. So here I get minus 2 plus 5. 5 plus 12. 12 minus 2 is 10. 10 plus 5 is here is minus 2. Again, 12. Here I'm minus 5. Correct. This is minus 5 here. Here's minus 5. So again, 12 minus 2 is 10. 10 minus 5 is 5. Thanks, Aziza. Who will do the second one? F of 0. F of 0. Just plug inside the function here. Is 3 times, correct, minus 5. 3 times 0 square plus 0 minus 5. So 0 square is 0. 3 times 0 is 0. Plus, we have 0 here, minus 5. 0 plus 0 is 0, minus 5 is minus 5. This is correct, Laila. We have minus 5. For the last one, f of 4. What is f of 4? Just plug inside the function. I get 3 times what? 4 squared plus 4 minus 5. Now 3 times what? 4 squared is 16. Plus 4 minus 5. What is 3 times 16? What's 3 times 16?
48.
48. 48 plus 5 plus 4 minus 5. 48 plus 4 is 52. 52 minus 5 is 47. So the answer is 47. Any question for this example? Okay. If no questions, let's go to another kind of function. It's called piecewise function. Piecewise function. So the piecewise function is a function that's made from like two rules like this. If I have the function, for example, c of x equal 39 and also equal 39 plus 15 times x minus 2. And this function has a domain if here f x between 0 and 2, and here this function if x is greater than 2. So my question is find c of 1/2. This is number 1. Number 2, find for c of 2. And number 3, find for c of 4. Okay. So for this question, you have to ask yourself, c of 1/2, where is the 1/2 should be, in the first interval or in the second interval? Then you have to plug this one inside the function has that satisfying the interval. So if 1/2 is inside this interval greater than 1, 2, you have to plug the 1/2 inside this function. Or if this 1/2 is inside this interval, you have to plug this 1/2 inside this function, because this is a piecewise function that's like made from two kind of functions. So now 1/2, where 1/2 lying between inside this interval or inside this interval? Which interval is correcting that 1/2 set?
The first one.
The first one, because 1/2 is between 0 and 2, is not greater than 2. So what is the answer for the c of 1/2?
39.
39. You should use this function. The answer is 39. Now for number 2, what is c of 2? What's the c of 2? Where is the 2 setting? In this interval or in this interval?
It's in the first interval.
The first, exactly, it's in the first interval. So the 2 is between 0 and 2, because here we have the equal. This is the equal sign. So the 2 is inside the first interval. Now c of 2, it's 39. We have to use the first function. For the third one, c of 4. The 4 is in first interval or in second interval? Amar said it's in the second interval. Yes, the 4 is greater than 2. It's not between 0 and 2. So which function would we have to use? So it's in the second interval. Which function we should use, the first one or the second one? And what's the answer? The second. And what is the answer? After I plug in the second one, it's in the second one. Yes, this is correct because the 4 is greater than 2. So we should use this function, Layla. Now, what's the answer after we plug the 4? After we plug the 4, what is the answer? 69. Okay, let's check. 39 plus 15 plus 15 times x minus 2 is 4 minus 2 is 2. Now 39 plus 15 times 2 is 30. And the answer is 69. Yes, this is correct. Anta, this is correct. 69. Any question for the piecewise function? Okay, so now let's go to the another part in this chapter called the net change. Net change. So the net change, I'm going to give like the formula for this one. So the net change of the function f of input change from A to B is f of B minus f of A. So the net change between the 2 points A and B is f of B minus f of A. This is the formula. So again, is f of B minus f of A. The net change of the function f of input change from A to B is f of B minus f of A. Okay, example. Let the function f of x equal x squared. Find the net change of number 1 from 1 to 3, number 2 from minus 2 to number 2. So the question is f of x equal x squared. Find the net change the question f of x equal x squared. Find the net change of from 1 to 3 from minus 2 to 2. Who will do the first one by using the formula in the above? So one is, the question is from 1 to 3. How can I do it? Again, the net change of the function f of input change from A to b is f of b minus f of a. The same things here. The net change, the question asks me the net change from 1 to 3.
F of 3 minus f of, f of 2, f of 1 minus f of 3.
You should to use the second one minus the first one.
Oh,
Okay, thank you. This is correct. So net change here equal f of 3, the second one, minus f of 1. So f of 3, after I plug into the function, what I get, Anta?
9.
9. So I get here 9 minus, what is f of 1 after plug inside the function? F
1.
squared? 1. And 9 minus 1 is?
8.
8. Thank you. This is correct. Now for the second one, who will do the net change? From minus 2 to 2. Minus 2 to number 2. Who will do the net change? Just plug inside the function here. Abu Bakr, would you like to do it? Okay, go ahead.
So you do f of -2.
You started from the second
F of
one.
2, f of 2
Okay,
minus f of -2.
this is correct. Now plug the 2 inside the function. This is my function.
You get 4
Okay, minus,
minus 4,
exactly. And what is the answer?
0.
0. Correct. Thank you. So the answer is 0. The net change from 2 to minus 2 is 0. 4 minus 4 is 0. Any question for the net change? This is what you should to know about the net change. And I have another example inside this section. Evaluate. So here, example. Evaluate a function f of x equal to x squared plus 3x minus 1. Evaluate for this function. So here for number 1, for 1, f of a. For 2, f of minus a. For 3, f of a plus b. I mean a plus h. And for the last one, number 4, for the quotient f of a plus h here, f of a plus h minus f of a and here over h. Okay, here we have, the question is, here we have square. Who will do the first one? Plug the a inside the function. Number one, f of a. Just plug the a inside the function. So when I plug the a inside the function, just remove the x and put it a instead. So I get here 2 times a square plus 3 times a minus 1. Again, when you plug the a inside the function, just you put instead of x, this variable x, a. Now I get 2 times a square plus 3 times a minus 1. Now we have to simplify the answer. Here I get a square, 2 times a square plus 3a minus 1. So we're done for the first one. Now for the second one, who will do the second one? F of minus a. Just to plug the minus a inside the function.
It'll be 2 times negative a squared
2 times negative a square, okay,
plus
plus
3 times
a.
negative a
Negative a, okay, perfect, minus,
minus 1.
this is correct. Thank you, Bilal. So now let's simplify this thing here. Here minus a square is a square, because the minus 1 square is positive 1. So I get here 2 times a square. 3 times minus a is minus 3a and minus 1. This is for the second one. Now for the third one, f of a plus h. Just you have to plug a plus h inside the function. Instead of x, you put a plus h. So let's do it. F of a plus h equal 2 times a plus h square plus 3 times a plus h minus 1. Now let's distribute the 2 inside the parentheses. So here I get 2 times a square plus 2 times the first term times the second term, as we learned before in the previous sections, plus the second term square. Here the 3 is distributed inside the parentheses, plus 3a plus 3h, and the negative 1 goes down. Now let's distribute the 2 inside the parentheses like this. I get 2a square plus 2a h plus, I mean here 4ah because 2 times 2 is 4 plus 2h square. Now I get here plus 3a plus 3h minus 1. We can simplify it more here. Let's check. Here we have a square. Here we have ah. We don't have ah again. Here we have h square. That's it. But you can put the a together. So I get here 2a square plus 3a. I mean, put this with this. And here we have 2h square, this number 2, with this, plus 2h square, plus 2h, 3h. Here we have 4ah. Here we have minus 1. That's it. Now for the fourth one. Number 4. For number 4, we just plug the f of a plus h we get from part number 3. This is part number 3. This is from 3. And f of a is part number 1. This is from number 1. Just put it together over h, and we have to subtract. So again, f of a plus h here, f of a plus h minus f of a over h. I have to put it. So here I get 2a square, this one, this here, plus 3a plus 2h square plus 3h plus 4ah minus 1 minus f of a minus f of a, this here. We have to multiply this by negative. So I'm going to write it down. Minus f of a is equal minus 2a square minus 3a plus 1. Just you have to change the sign or multiply this by negative. So now here minus f of a, you have to put this one minus 2a square minus 2a square minus 3a plus 1 and everything over h. We can simplify it more here. Look, the 1 goes with this one because minus 1 plus 1 is 0. Minus 3a with the 3a is 0. And minus a square with the 2a square is 0. The only left here 2h square plus 3h plus 4ah over h. So I'm going to the next slide. This is equal 2h square plus 3h plus 4ah. Everything over h. We can simplify these things. What is the simplify? What is the factor for the numerator here? What's the factor for this one?
H.
H. So we take h outside. Here we left is 2h plus 3 plus 4a over h. Now the h with the h, they cancel out. The final answer is equal This is equal 2h plus 4a plus 3. Any question for this example? Any question? It's easy, just step by step. First step is f of a, you plug the a inside. Here I get a question, would not be minus 2 from the previous part? Which previous part? Would not be minus 2 from the previous part. Minus 1 and minus 1 does not cancel each other. Here I have positive 1 and negative 1. Here I have negative 1 and here I have positive 1. So they cancel each other. You ask about this, right? Negative 1 and plus 1 is 0. Again, so f of a, you plug the a inside the function, I get 2a squared plus 3a minus 1. You plug here f of minus a, you plug it inside the function, the same idea is 2a squared minus 3a minus 1. You plug a plus h inside the function, here 2 times a plus h squared plus 3 times a plus h minus 1. Here the square, as we learned from previous section, is the first term square plus 2 times the first one times the second one times the second one square. The 3 distributed inside the parentheses, I get 3a plus 3h minus 1. And after we simplify it, we get 2a squared plus 3a plus 2h squared plus 3h plus 4ah minus 1. Now for the fourth one is by using from part 3 and using part 1, and we combine together. After we combine together, there is something we cancel. The minus 1 with the 1, and the minus 3a with the 3a, and also the minus 2a squared with the 2a squared. The only left is 2h squared plus 3h plus 4ah, everything over h. Now we factor the numerator by h. They factor the numerator, and the h with the h, they cancel each other. So I get 2h plus 3 plus 4a, or 2h plus 4a plus 3, the same things. The last example in this section is the last one is find the domain of the function. Just I want to remind you what is the meaning of domain. Domain mean is all possible input for the function. This is the mean of the domain. Find the domain of the function. So the first part of this example is the function is given as number 1, f of x equal x minus 9 over 9 over x. Number 2, g of x equal square root of x square root of x minus 8 minus 18. The third one is h of x equal x squared minus 3x. Okay, so the question is find the domain. The domain is the all possible input for the function. All possible input for the function. or I can define it in different way. All input, or is the set or let's like I'm going to use the same definition, possible input, or is all set all possible input for the function. Yes, or is a set that's make the function like set has a value that make the function define. So let's check this function first. Can I plug the positive numbers inside this function? Like 1, 2, 3, 4, 5. Can I plug the positive numbers inside this function? Or in different way, in which value of this function, if I plug the value for this function, they will give me undefined. So let's starting from the positive numbers. If I plug like 1 inside the function, f of 1, what is the value? 1 minus 9 over what? Over 1. And I get minus 8, right? So actually they give me a value. What about the 2? If I plug the 2 inside this function, f of 2. The same things, they will give me a value, 2 minus 9 over 2. And 2 minus 9 is minus 7, exactly, minus 7 over 2. So still give me a value. And if I keep going here, like 3, 4, 5, they will still give me a value. What about the negative numbers? Can I plug negative numbers here inside this function? Like f of minus 1. Yes, they will give me a value. So it will be fine. What about negatives f of 2? Everything fine. What about the 0 here? Can I plug the 0 inside this function? Can I plug the 0 inside this function here? Can I get 0 minus 9 over 0? It's fine. I get minus 9 over 0. No. So the function is not defined at 0, but it defines everywhere. So how can I define here the domain? What is the domain for this function? What's the domain for this function? So the function is defined everywhere except the 0. So I can say here x such that x not equal 0. This is the domain. All values, all real numbers except the 0. Makes sense? Now for the third one, let's go to the third one. I will go back to the second one. Can I plug 0 here inside this function? Can I plug the 0 inside this function? F of h of 0, they give me what? 0 square minus 0. Give me 0. This is fine. Can I plug positive numbers like 1? Yes, will be fine. They give me 1 minus 3. And they give me an answer. And the same things for all positives. Can I plug negatives like negative 1? Give me minus 1 square minus 3 over minus 1. They give me answer, so it's fine. So what's the domain here for this function? The domain is all numbers, the 0, the positive, the negatives, all of them fine here. So how can I define it? What I should to do here? What is the domain? Real numbers, exactly, from minus infinity to infinity positive. Or I can say here are real numbers. Now let's go for the second one. The domain here, like the numbers, should I plug inside this radical, must be positive. X minus 18 here must be positive. I cannot plug inside this radical any negative numbers like we said before. This is mean x minus 18 must be positive. So how can I make this positive? Any idea? Any idea how can I make this positive here? Or what I should to say here? By using the inequality, the previous section. Okay, these things here must be positive. This means x minus 18 must be greater than or equal what? 0. This here must be positive. This is mean x minus 18 must be greater than or equal 0. Now we solve this inequality. What we should to do for solving this inequality, like previous section, we have to add 18 for both sides. After I add 18 for this side, I get what? 0. So x must be greater than or equal 18. So all positive number greater than 18, Abu Bakr. 18 is not 19. So I can say here the domain is x such that x is greater than or equal 18. This is my domain. Again, why I should say like this? Because under the radical must be positive or 0, cannot be negative. So I have to use the inequality from the previous section, 1.7. So x minus 18 is greater than or equal 0. I should to add 18 for both sides. Then I get x is greater than or equal 18. So the domain is x such that x is greater than or equal 18. For the first one, can I plug any numbers except only the 0? Cannot be the 0 inside the denominator because any number over 0 will be undefined. For the last one, the third one, I can plug positives and negatives and 0. So the domain will be the all real numbers. Okay, we're going to stop up to here today, and I will see you next time. Have a good day.
Professor, I have a question.